Using differential approach, somewhat synergic to differentiation concept, to maximize it, we use plus. Now look at that. How would you differentiate? First function, derivative of the second, and then reverse. Just drop the bottom and replace d by delta. Very fast way of doing things. You already got your answer, but just to get it in that form, delta z by z, we divide both sides by z. So fast, isn't it? So what I'm trying to say is that we obtain these results following different approach, but differentiation concept works very well in error analysis. If we want the result for division, z equal to a by b, then see how quickly we can get it using differentiation approach. So when we have z equal to a upon b, then I'm directly using the differential approach. Delta z, how would you differentiate? Square of the denominator, copy the denominator. In place of whole d by d, I'm just using differential. Right? That's it. Done. That is something like differentiation of division type of case. Now, if I want delta z by z type of result, then I would divide both sides by z. So delta a by a minus delta b by b. See how quickly we got it. And now you would say one more thing. You would say that you are looking for maximum error. So maximum error would be when these errors add up. These errors add up. When one is the positive error, other one is the negative error. That's where they will add up, right? So the maximum error, if you want, it would be obtained by adding the absolute positive. Absolute positive. So these are mods, you are adding them, and that's the maximum. So if your answer is 2 plus minus 0.3, then 0.3 cushion takes care of the maximum on both sides, 2.3 to 1.7. Your answer is anywhere between 1.7 to 2.3. So smaller errors would be within this 0.6 margin. Right? So I hope the differentiation approach is understood, which is a very powerful approach for error analysis. If you have any questions up to this point, addition, subtraction, multiplication and division, then just let me know, or I will take some problems. Yes. Okay, I can see that pointer. Oh, we have divided. We have just divided. So what we got was delta Z equal to A delta B plus B delta A. Then we chose to divide by Z on both sides. And Z is equal to AB. Z is equal to AB. So this is Z, this is also Z. But I have chosen to write AB in place of Z here. If there are any other questions, let me know. Now, by the way, what is delta A by A? Relative error. Delta B by B, relative error. You are measuring two quantities A and B, and then you are calculating Z. Delta Z by Z is the relative error in Z. So relative error in Z is equal to relative error in A plus relative error in B. That happens for multiplication, that happens for division. Please try this. %. Relative errors add, and percentage error is nothing but relative error into 100. So percentage errors should also add. Percentage errors should also add. That means 100 plus minus 5. That means 5 is a percentage error. I hope you get that point. Why is it a percentage error? Because this is out of 100, and 0.2 is for 10. So for 100 it will be 2. So 5% voltage error, 2% ampere error, and the total error would be 5 plus 2, 7%. That's very good. If there is any question, then just let me know. I think the second one would be challenging. It would involve differentiation. Second one. First one I think you can answer easily. Yes, first one. How come 11? Series connection? Yes, 7. Series connection means R equal to R1 plus R2. Yes. So errors would also add, absolute errors would also add. Plus minus 3 means absolute error is 3, absolute error is 4, 7. Right. 300 plus minus 3 plus minus 7 is correct. If anybody has problem with this, let me know, or we move on to the second part. You can also try second part. Try it first and then I will discuss it. You may have to differentiate here because we don't have formula for this case. We have discussed addition, subtraction, multiplication and division, and this does not belong to any of those 4 cases. Okay, I think I will discuss it. Can you just tell me R value that you are getting? Just R value. I will do the error calculation. 11 by 24, 200 by 3. I think 200 by 3 should be correct. Okay. Now, coming to error part. This would have been the answer, 200 by 3, provided 100 and 200 were absolutely accurate. Okay. You are getting 44 by 9. Let me see. I think you may have to check your workings. So how do we find delta R? Just differentiate with respect to anybody. If you use differential concept, then with respect to whom that point does not come. Differentiation of 1 upon x, x to the power minus 1. That is minus 1 upon x square, isn't it? In place of writing d by dx type of thing, I would just write differential. Then here also it will be the same story. Differential in R1, change in R1, that is. Differential in R2. I want delta R. Delta R by R square is delta R1 by R1 square plus delta R2 by R2 square. If there were minus sign, it should have been changed. It should be changed to the plus sign because we want maximum possible error. But it is already positive for us, so we don't touch. Looks like we already got it. Delta R is given by delta R1 by R1 square plus delta R2 by R2 square whole multiplied by R square. I hope now we have understood why it was so important to discuss the differentiation approach. If the problem does not belong to those 4 categories, addition, subtraction, multiplication, division, now you are capable of handling any variation. Can you just calculate this? (16 by 9) is 1.77. Yes. Now 200 by 3. That means 66.6666. And 16 by 9. One point 777. Can somebody else also confirm this, by the way, 16 by 9 thing? Though it is looking okay, looking at the answer that I have, still, the answer that I have is in decimal. So in fractions, are you getting 16 by 9 only? Yes. Yes, I can see that pointer. Tell me what exact doubt you have there in that step. That is the formula for 1 by x that has been used, d dx of 1 by x. That means the d dx of x to the power minus 1. And d dx of x to the power minus 1 would be minus 1 x to the power minus 1 minus 1. That is minus 1 by x square. If you have any other doubt in that, then let me know. And meanwhile, I have verified this thing. It is indeed 1.7777, so I think 16 by 9 is correct. Yes. And now let us think, does it really make sense to give so many decimals if we are not even certain about this? At the most, we can go up to this. Looking at the error, if error is right here, then it is simply useless to go so far. Let me know if you have any questions. Addition, subtraction, multiplication, division, and some general thing also you can handle. But still we discuss power case as a special case. Power. This can be thought of as multiplication. A multiplied to A. And if A is multiplied to A, then this is what we have, which means 2 times delta A by A. That means when you have power, it just comes out. When we take 3A into A cube, again it will become this plus 1 more, giving 3 here. If you have 4, so I hope by now it is clear that when you have power, then the power comes out. Again, this should remind you of differentiation. For example, if you differentiate this, in place of dz by dt, I am writing just delta z, twice A delta A, dividing both sides by z, right side writing z as A square, and that's done. Any questions about power? If you have, then just let me know. How about a combination of various things? No problem. Multiplication. Multiplication means let me do it step by step. Division means division of two fellows means relative errors are going to add. Now look at the relative error in a to the power 4, b to the power 1 by 3. This is a multiplicative thing, this into that. So, multiplication means relative errors are going to add. Relative errors are going to add. Multiplication means relative errors are going to add. Relative errors or percentage errors as applicable. But for power means power just comes out. Power means power just comes out. Power means power just comes out. And I think we are done. If you have any questions regarding this case, then just let me know. Try this. Let me check. Can you check your working? Your answer is close. But still little far away. Perhaps I should draw one point to your attention. What happens when some fixed number is multiplied to the calculation? Let's say you are trying to calculate something like this. Where k is a constant, right? Some fixed constant, not a measured value. So in such case, the uncertainty in k, there is no uncertainty in k. It is not a measured number, right? So that's what happens in case of addition. But in this problem, t equal to 2 pi root L by G, 2 pi is a constant. So if you have something like this, z equal to k times AB, k times AB, then what would you say? relative error in Z equal to relative error in K plus relative error in A plus relative error in B. And then you would say, well, K is a constant, so delta K should be 0. So you see again, K is not coming. In this question, that point will be valid, what I have tried to say here. Well, the answer is 3%. Answer is 3%. So see, you're working, and if you would like this to be discussed on the board after that, then raise your hand. Fine. We want G measurement, calculation. We want G calculation. Measurement is done for two things. We want G calculation. Measurement is done for two things, L and T. T square would be 4 pi square L by G. That means G is 4 pi square L by T square. Now delta G by G, delta 4 pi square by 4 pi square, that is 0. Delta L by L, delta T square, 2 delta T by T. If you have any question up to this point, let me know. Fine. Now we want accuracy in determination. Let's say we want percentage error, delta L by L. Measured value of L is 20.0. Accuracy is 1 millimeter. In centimeter it is 0.1. Now, how to calculate delta T by T? One oscillation, pendulum takes the time in one oscillation, that is capital T. But when you do this experiment in your lab, you don't calculate time for just one oscillation, but you let it oscillate several times. In this experiment, 100 times, let it oscillate 100 times, measure the total time. That's a smarter way of doing things, of reducing error, than taking just one oscillation. So you go for 100 oscillations, and for 100 oscillations, if it takes 90 seconds, then you say for one oscillation how much would it take? I think 100 number won't come. You see, for 100 oscillations it is taking 90 seconds. Or let me say for n oscillations it is taking t seconds. So for one oscillation it takes t by n. That is capital T. Small t by n is capital T. Then your instrument has 1 second resolution. So error in measuring this total time of 90 seconds is just 1. Delta T is the resolution of your instrument or stopwatch. In fact, it is wristwatch. Wristwatch is used for this purpose. For wristwatch, it should be 1 second normally. So delta T would be 1 by n. 1 by n. T is 90 by n. So n is not really affecting delta T by T. Delta T by T is same as delta small t by t. That means 0.1 by 20 plus 2 times delta t 1 second by t, which is 90 seconds. Can you calculate this now? See how much you get. In fact, that first answer, 2.72%, that's exactly what it is coming out to be. 2.72. 2.7222. Yes, if you want percentage error, then we should also write 100. So into 100, into 100, into 100, into 100, into 100. Now the answer that I have is 3%. How is that happening? Let me double check. Okay, so that could be an error in the NCERT textbook. So that's what it is coming out to be. So many decimals are not required. So 2.7% or close to 3%. That's it. Any questions? If you have, then let me know. I think you should find this one easy. Density. It's wire, so we assume it to be cylindrical. It should be as simple as that. Then multiplying everywhere by 100. So what do you think is the answer? Option D. Yes, option D. Any questions if you have regarding this, let me know. Yes, 6% is the answer that I have. If anybody has problem with this, let me know. If you would like this to be discussed on the board, then raise your hand. Okay. Very well. We stop at this point.